We have chapter 8.5. We're still dealing with linear equations. We are going to in 8.5, we're going to determine an equation of a line. So to find an equation of a line given the slope and 1 point on the line, or given 2 points. So we're going to be given different pieces of information, and we're going to have to put it in slope-intercept form. Y equals mx plus b, where m, this is important. So, oh, now that's interesting. Oh, that's because I pushed the button, sorry. So y equals mx plus b, where m equals the slope. Sorry, I'm getting my handwriting back. B equals the y-intercept. It's where the line crosses the y-axis. And x and y are a coordinate. It's a coordinate. It's a solution. It's a point on this line. So each of these things are filled in. Now, when we write it as an equation for all of the solutions, we write it leaving the x and y because there are an infinite number of solutions to this equation. So we leave those open, and then we show the slope and the y-intercept because those are constant. The place where this line is going to cross the y-axis is always going to be at 2 on the y-axis, and the slope from one point to the next is always going to be up 3, right 1. That's never going to change. It's a constant rate of change, as they say. So write an equation in slope-intercept form for each of the lines described. So if we're going to fill in for y equals mx plus b, then we're going to fill in for m, which is the slope, and we're going to fill in for b, which is the y-intercept. So we fill that information in, keeping y open. M is going to be 2, x is going to still be the variable, and then the y-intercept is going to be 3. As easy as that. Y equals mx plus b. Yeah, right? Look how easy this is. Y equals mx plus b. 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 You're thinking, it's got to be harder than this. Well, when they give you the slope and the y-intercept, no, it doesn't have to be any harder than that. Y equals mx plus b. Now, notice this time my y-intercept was negative, so it would have been plus a -6, which simplifies to just -6. Y equals mx plus b. Y equals mx plus b. Y equals mx plus b. That's it. So when they give you, so that's the easiest, that's the vanilla one. When they give you the slope and the y-intercept, it's very simple for you to plug in those two values into the template. I call that the template, y equals mx plus b. Now they're going to give us this, the slope. So they give us a slope, but they give you a point. So remember, if we're using the template y equals mx plus b, and we have to fill in, it's not an equation until we fill in this, well, we may have to do a temporary step. So yes, we can fill in for the slope, which is -2, but we're not given the b, so we're looking for the b, but we are given an x and a y in this case. So we're going to fill in 0 for y and 5 for x. So notice we can still find out what it is because we only have one variable. So we just simplify. you get negative 10 equals b, and then you add 10 to both sides, and we get 10 equals b. Now we have the y-intercept. We already had the slope, so now we can plug those in. Y equals negative 2x plus 10. And there's our equation. So that's how we're going to do this. We plug it in for the y and the x, and then we solve for the y-intercept. So we start off with this equation, y equals 2x plus b. Why did I start off with 2x? Well, because I already know what the slope is. So I can fill that piece of information in. Well, why didn't you fill in for x and y? Well, this is just my first intermediate step. Over here, I'm going to take that information, and I'm going to plug this in for x, and I'm going to plug this value in for y. So I'm going to use this equation right here. I'm going to write negative 1 equals 2 times the x value, which is 3, plus b. Now I'm going to simplify. I'm going to subtract and isolate b. And then I'm going to write my final equation here, 2x minus 7. So that's my answer. So that's why I'm just showing the steps of what I can fill in, knowing that I have to fill in for the slope and the y-intercept. All right, so y equals 3x plus b. Let's fill in for x and y. So y is 2. My slope is 3, my x is negative 1, and then I'm solving for b. 2 equals negative 3 plus b, add 3, 5 equals b. And now we can finalize this equation, filling in for the slope and the y-intercept. So slope, y-intercept are the things that we need to be able to fill in into these equations. That name for the linear form tends to tell us what information they give us. So, y equals negative 4x plus b. Let's plug in x and y. So 3 equals negative 4 times 2 plus b. 3 equals negative 8 plus b, add 8. We're just isolating b. We get 11 equals b. And my final answer is negative 4x plus 11. Yeah, my handwriting definitely is affected by this, this tablet. It's not the best, but at least I can do work on the weekend at my house, which is one of the nice benefits. So we'll plug in x and y. So 1 equals negative 2 times negative 3 plus b. 1 equals 6 plus b minus 6 minus 6. Negative 5 equals b. So y equals negative 2x minus 5. Y equals 2/3 x plus b. Let's solve for b by plugging in the x and y of a point, because our x and y, there are an infinite number of points I can plug in. I'm only provided one, so it passes through this, so I know that it's a solution for this equation. So that's why we're plugging in these values, and we get 3 equals b. Oh, b, it's the y-intercept. Well, yes, of course this is the y-intercept, because what do we know about all y-intercepts? It has an x value of 0. So we kind of didn't need to do any work there. It was really provided us in the, when they told us the point was 0, 3. So that's a little tricky problem there. We could have done, this is the x-intercept, but remember, none of those variables represent x-intercepts. It is just the y-intercept is b, x and y are the points, and m is the slope. So we are provided the slope, we're provided an x and a y, so we will utilize those. 0 equals negative 4/3 times 1 plus b. 0 equals negative 4/3 plus b. We'll add 4/3 to both sides. 4/3 equals b. So my final equation is y equals negative 4/3 x plus 4/3. Whoa, that's an interesting one. Let's check, make sure that all is good. Yep, that went in for x. It was negative, becomes positive. Excellent. All right, so first equation, I'm going to write y equals negative 3/5 x plus b. This is my x, this is my y. Negative 4 equals negative 3/5 times my x value plus my b value, which I don't know. Negative 4 equals 3/5 plus b minus 3/5 minus 3/5 gives you negative 4 and 3/5 equals b. So my final equation is y equals negative 3/5 x minus 4 and 3/5. No, that was a bad 5. Well, let's just erase all that. 3/5. There's not very many times I'm going to write a mixed number, but this is okay because when we have to graph this later, you know, it's going to be on a grid line, so it's in my best interest to know that it's 4 and 3/5 opposed to negative 23/5. I don't know if I know exactly off the top of my head where that is, so having it as a mixed number is nice. Plus b. Typically we're not going to write negative 1, but because we're using, this isn't my final answer, I'm just going to write that so I can visualize the plugging in and the solving. So negative 3 plus b, add 3, add 3. We get 4 equals b. So my answer is y equals, now I'm going to take away that negative 1 and just write the negative plus 4, because that's the better way. You would never write y equals negative 1x plus 4. That would not be appropriate. 0x plus b, this is going to be a fun one. I like this problem. So 2 equals 1/4, equals 0 times 1/4 plus b. 2 equals b. And then we get y equals 2. There is no x value because my x coefficient is 0, so I shouldn't see an x anywhere. This is the proper final answer. It's going to be a horizontal line going through the y-axis at 2. So that's a good example. That's one of those unique and interesting ones that will test your understanding, hence why it's one of the last ones. Y equals 0x plus b, same thing, xy, 3/8 equals 0 times negative 2 plus b, 3/8 equals b. So we would have y equals, this is going to cancel out, 3/8 would be our answer. Was an interesting tail there. Okay, example number 3. Now they just give you 2 points. So remember, if we're going to fill it in for slope-intercept, we have to find the slope and the y-intercept. So since we're not provided the slope, we're only provided 2 points. We're going to do x sub 1, y sub 1, x sub 2, y sub 2, and then we're going to calculate the slope, and then we're going to plug it in, and then we're going to plug in one of these two x and y's, and then solve for b. So we just have one first step. So the first step is find the slope, So finding the slope, that's x sub 1, y sub 1, x sub 2, y sub 2. So remember, slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is 1 minus y sub 1 over x sub 2, 2 minus x sub 1, which is 4. That gives me negative 4 over negative 2, which gives me a positive 2. So here's my first equation, y equals 2x plus b, much like I did before. And now the second point is I'm going to use one of these points to plug in for my x and y. So I'll just pick the first one. So I'll have my y is 5 equals 2 times my x, which is 4, plus b. 5 equals 8 plus b minus 8 minus 8. Negative 3 equals b. Now I have my y-intercept, so I have my slope. I have my y-intercept, so I can write my final equation, y equals 2x minus 3. Nice and logical, really good, efficient, makes sense. X sub 1, y sub 1, x sub 2, y sub 2. So let's find the slope by doing y sub 2 minus y sub 1 over x sub 2 minus x sub 1, 2 negatives there. So that's 5 over 5, which gives me a slope of 1. So we have our equation 1x plus b. Let's pick a point. I'm going to pick that first point again, and I'm going to plug in 2 for y equals the slope, which is 1 times the x value, which is negative 1 plus b, because I don't know, that's what I'm solving for. Add 1, and we get 3 equals b. So y equals, I'm not going to write 1x, I'm just going to write x plus 3. That's the proper notation for that. X sub 1, y sub 1, x sub 2, y sub 2. The slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. 2/3 is my slope. Y equals 2/3 x plus b. Let's pick a point, or still pick 1, 2. So 2 equals 2/3 times the x value, which is 1, plus b. 2 equals 2/3 plus b minus 2/3 minus 2/3. I know how to subtract, so that's 1 1/3 equals b. Another instance where it's in my best interest to keep it as a mixed number. And there it is. X sub 1, y sub 1, x sub 2, y sub 2. First you got to find the slope, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. 2 over 1 is a slope of 2. So y equals 2x plus b. Let's find, have I been writing 2? I don't know. Yeah. Let's plug in the value. We'll still use the first point. So my y value equals my slope times my x value plus b. Simplify. Minus 6 minus 6. Negative 2 equals b. So y equals 2x minus 2. X sub 1, y sub 1, x sub 2, y sub 2. They're going to get tricky soon. This is not a tricky one. The slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which gives me 1/2. Y equals 1/2 x plus b. 2. Let's pick a point. 1 equals 1/2 times 3 plus b. 1 equals 3 halves. I should be able to multiply a whole number times a fraction. That is super easy. Minus 3 halves, minus 3 halves. Hopefully you understand that that is negative 1 half. 1 is equivalent to 2 over 2. So 2 and negative 3 makes negative 1 halves. Y equals 1 half x minus 1 half. Nope, not yet. So x sub 1, y sub 1, x sub 2, y sub 2. My slope equals 2 minus negative 2 over negative 3 minus 0, which is 4 over negative 3. My first is y. Oh, I don't think I write that. I'm just writing the equation. Y equals negative 4/3 x plus b. Step 2, plug in a point, 0, negative 2. So negative 2 equals negative 4/3 times my x value plus b. Negative 2 equals b. That's a nice one. Again, this is the y-intercept. So I could have immediately written this statement, but we like practicing the work. And there you go. So they did start giving us some tricky ones. This is the y-intercept. So all I would really need to do is find the slope, x sub 1, y sub 1, x sub 2, y sub 2. So the slope is going to be 3 minus negative 1 over negative 2 minus 0, which is 4 over negative 2, which is negative 2. So I could actually write the equation right now, 2x minus 1. But you have to understand, you have to be astute to see that this is the y-intercept. How do I know it's a y-intercept? Because x is 0. Every x value, when x equals 0, I know my y value would be considered the y-intercept. It's where on the y-axis and where it crosses on the y-axis. So we could save a little time doing that. X sub 1, y sub 1, x sub 2, y sub 2. Slope, I know I didn't write that in the last problem, but we kind of knew what we were doing. 1 minus 4, 2 minus 6. That's negative 3 over negative 4, which equals positive 3/4. We always have to simplify our fractions. Plus b. And then let's pick a point. 4 equals negative 3/4 times 6 plus b. So 4 equals, that's a 2, that's a 3. So we get 4 equals 9 halves plus b. We're going to minus 9 halves, minus 9 halves. And we should know that that gives me negative 1 half, because I know 4 is equivalent to 8 halves. So y equals 3/4 x minus 1 half. So these things that we should know. That means you should know this stuff in 8th grade. Should be very, that's mental math stuff. We should be proficient with fractions, and you should be able to do that without writing things down. You should be able to do mental math. And if you can't, then you need to put some time aside and you need to start working on that, because that's a bad indicator if you don't know these things. That's not acceptable. That is not on the standards for 8th grade. By 8th grade, you should know how to add and subtract fractions. Those are the basic fractions. So that's something, if it is happening, which, okay, we get it. Not the best, but not the worst. But you can't not address it. And that's the most important thing, is if it's being brought to your attention, then address it. It's going to take some time. You may have to make some sacrifices, but address it, because it's not going away. You're going to need to know fractions in high school. So that's just my advice for students when we see things, decimals, fractions, multiplication, times tables, division, whatever that concept or that that concept that, what would we call it? I don't know what we'd call it. That skill. If you're deficient in it, then address it. You should be able to do all this stuff, mental math. Y equals, oh, that's a positive 3, Mr. Mac. 2 negatives make a positive. Y equals 3x plus b. Let's pick a point. And we have 3 equals 3 times 0 plus b. Again, we should have seen that that was the y-intercept. But sometimes we're just so bought in to the process that we don't recognize that's the y-intercept. It's okay. This is taking 10 seconds. And, you know, we're still getting it done. X sub 1, y sub 1. We always talk about this piece also. So we're on problem number 31. Good. Good. We love that there are 31 problems for you to practice, but I've gotten every single one right. Again, great. That's not a bad thing. This is a good thing that you should not shy away from and go, okay, hard work, heavy lifting, doing lots of work. Well, yes, that's what we want to be practicing. And being proficient is going above and beyond and doing all of the extra work and making sure we are proficient. And even at the expense of eating up some time. 2 equals b and y equals negative x plus 2. Did you write the negative 1? If you wrote the negative 1, that's not good. Hopefully you just wrote a negative sign in front of the variable x to represent the negative 1 slope. So that's something you can judge yourself on and see if you are doing that correctly. Negative 1 minus negative 7. Did you do those negatives correct? 2 minus 1, which is 6 over 1, which gives us 6 as a slope. So y equals 6x plus b. That was part 1. Part 2, pick a point. We'll pick negative 7 for y. 6 times 1 for x plus b. Negative 7 equals 6 plus b minus 6 minus 6. Negative 13 equals b. And my equation is y equals 6x minus 13. Couple more. Okay, well, a little bit more than a couple. Ooh, notice. Did they do that in the last one? I don't think they did. No, they give us 2 points. Now they give us the x-intercept and the y-intercept. So that's good. So we know 2 things. So one of the things that we know is the x-intercept, that coordinate. These are 2 points. This is the point 0, negative 1, and this is the point 4, 0. We know that in the y-intercept, my x is always going to be 0. We know in the x-intercept, my y is always going to be 0. Now, I don't necessarily need this. I'll show you a couple methods because we got a couple problems over here. So I'm going to do this first. I'm going to put in the x and y. I'm going to put my y value in equals my slope, which I don't know, mx plus b, or minus 1. So I'm going to do it in this fashion. Equals 4m minus 1. We're going to add 1. We have 4m. We divide by 4, divide by 4. So 1/4 equals my slope. So that's a very, very unorthodox way to do this problem. I don't think I've ever seen it done this way. So we have y equals, I know what my slope is, x, and I know what my y-intercept is, negative 1. That's not a bad way to do it. I like that technique. That's a really smart technique. Here's the other way we can do it. So we know that this is the point 0, -4. We know this is the point 1, 0. And we can use this as my x1, y1, x sub 2, y sub 2. So we can do 0 minus -4 over 1 minus 0, which gives me 4 over 1, or a slope of 4. Knowing that my y-intercept is -4, we can write the equation y equals 4x minus 4. So which way is easier? That's up to you. You can use this technique. You can use this technique. But each one, we're utilizing that we have to fill in for each of these variables and only have one left over. And with the understanding that we have to fill in for both of these for it to be an equation in slope-intercept form for the described line. So whichever way you want to do it, there's really no right or wrong way. It's just whatever you're comfortable with. I'm going to stick with the x-intercept is -4. Did they just switch that? My y-intercept is 0 and -3. Did they switch the x and y? Yes, they did. So they just want to make sure that you know where to put the 0. So when you have the y equals -3, y-intercept equals 3, that goes into the y value. And then I know that 0 goes in for the other variable. So we're going to use this point. We can't use this if we're going to fill in and use, if we're going to fill in for y equals mx plus b, we cannot fill in for this and plug -3 in for this. We have to use this point with this y-intercept. So it must be 0 equals, I don't know what my m is. I know my x is -4 and -3. So if I'm going to use this for my y-intercept and plug it in for b, the point that I plug in must be the other point. So that's the only stipulation, I guess. -4m minus 3, add 3, add 3. 3 equals -4m, divide by -4, divide by -4. -3/4 equals my slope. So y equals -3/4 x, with my y-intercept being -3. All right. 3 more. Horizontal line through -1, -2. So if we have a graph and a horizontal line through 1, -1, 1, 2, so this point, if it's going to be a horizontal line, let's change the color just so we can distinguish it. Horizontal line is going to look like that. So we know that the slope is 0. Hopefully you know the slope is 0. And what's the y-intercept? And hopefully you know the y-intercept is -1. So I can write an equation for that information using y equals mx plus b. So y equals a slope of 0 and a y-intercept of -1. That simplifies to y equals -1. Remember, horizontal lines and vertical lines are only going to have one variable in their equation. So that was the tricky part. Horizontal line through -2 or 2, 4. So we, again, if you need to, 1, 2, 1, or excuse me, 1, 2. Did I do that one right? Maybe. I hope I did. I didn't do that correctly. I graphed it incorrectly. The concept, the idea is correct, but I made a major boo-boo in graphing my point. Can I have that, please? Oh, we'll leave it for the time. We'll use it. I'm sorry. I made a huge mistake. That's -1, -2 is right here. Sorry. So it does change a lot of things. The slope is still 0, but it crosses the y-axis at -2. So that is 0 for x, -2 for y. So, sorry. I kind of felt that. I kind of felt like I made a bit of a boo-boo. 0x minus 2, and so we get y equals -2. Sorry. 2 on the x, 4 on the y goes here, and it's a horizontal line kind of going through there. That's better. So my y-intercept is going to be that point, which is 0, 4. And we know the slope is 0, so y equals 0x plus 4, or y equals 4. You would need to simplify that. You can't leave 0x. A vertical line. So now we have a vertical line. Sorry. We have a, oh geez. We have a vertical line going through -1, -2. So this time the vertical line looks like this. Let's move it over a little bit. Let's move everything over a little bit. Well, that didn't work. Ungroup, group, ungroup. Let's move that over. Let's move that. Move my dot, please. No, okay. Then move that for me. Ha! Told you. You thought you were going to get me. Not the case. Perfect. Okay. So this time, notice, what is this? This is my x-intercept. And my equation asks for the y-intercept. So it asks, so when we put it in y equals mx plus b, first of all, there is no y-intercept because it never crosses the y-axis. And what do we know about the slope? A vertical line has no slope. So we can't describe it. This is actually written x equals -1. That's the equation for that. That is a major tricky question right there. And that was the last one. So hopefully you see all the fun components of this. And it's not the easy ones that are going to be on the assessments. It's always going to be problems like 38, problems like 39, 37, and all those little tricky ones. So make sure you're taking the time to ensure that you know all of it, deep, all aspects of it, not just the most basic components.